So this is going to be the second video with hints from our random walk and random number generating homework. I'm going to cover two topics. I'm going to cover the Fick's law problem and the moments test. So we went over a little of this in class. So I'm just going to go over Fick's law, how to set up the code, which I have here. Okay, put this here. So there's our equation. So here's how I set up my code here. So pretty standard stuff. All my include files. I have a main. I have some definitions here. So our main variables that we're going to work with is our delta t, delta x, and diffusion constant. And those are all found from the previous problems. Well, the diffusion constants from the previous problems, you can play with delta x and delta t. And that's why delta x and delta t here are defined as constants or definitions. Time, I'm going to go 1,000 time steps. And then I have this constant. I could have just called this a definition, but another way you could do is a constant integer. When I define an array like this, and I give it this length, this can't be a variable. So I couldn't make an int called length and define that as 10. It has to be a constant. Or you can just allocate using malloc any way you want. That's fine. So I can make a variable int that's length, call it 10, and then use the memory allocation to make my array. But if I'm going to just call it like this, what's in here needs to be a constant. Like you could just put in the number 10, or you can have a constant or a definition put in there. So I'm setting up my length. So that aside, I'm going to set up how long I want my 1D space to be. And I'm going to do it where I'm going to take into account that there might be that one lucky random walker that just goes one direction the entire time. So I'm going to set up, essentially let it go twice the time step. So I have 1,000 time steps, so it's going to be 2,000 units in length long with my 0 in the middle. And I'm going to divide that by delta x. Here I have it as 0.1, so that means my length is going to be 2 times 1,000 divided by 0.1, so I'll have an array that's 20,000 spaces. And I define it here. And so I call this a constant int, so because it has to be an integer, because when I declare arrays, the length has to be an integer. And you see I'm declaring two arrays. I have this concentration, the C array, and the C new. And we talked about this in class, that here's our C new. This is C in the future, T plus delta T, and this is our concentration at T, and this scans over the whole thing. So we're looking at X. Our future X is dependent on our present X, and the present X to plus delta X, and the present X minus delta X. So the first thing I do, I'm just going to initialize these, set them all equal to 0. So just a for loop, setting all 0. And then in the middle of my space, I'll call it this integer h, which is just half times the length. I'm just going to set it over to a number. It doesn't matter what. A lot of people use 1. I'll just say, oh, I have 10,000 random walkers here, so I'll set it to 10,000. And then you set up your time loop. So this is your time loop. So time starts at 0 or 1 or however you want to do it. Doesn't really matter. You go to your final time, which is I just define here, and time increments. And then here's where you actually do the program, the equation here. I'm not going to do the whole thing, but you're going to set C new of I is going to equal the right hand side of the equation. Right hand side. So this is where you do that math. I'll just comment that out. So C new equals that, and this is, remember, this is dependent on C of I C of I minus 1 and C of I plus, right? Because our I here is length. So each space and length is a delta, has delta x spacing. So I of 0 covers negative negative say negative 1,000 here to 1,000 plus, negative 1,000 plus 0.1 in this case. So our C nu of x, which I is x here, depends on the current position, the position to the left, and the position to the right. Now you need to be careful here because say I equals 0. If I equals 0, then this one doesn't exist, so you have to make an if statement or account for that. And if I equals length minus 1, this one doesn't exist. So you have to make sure you don't step into those arrays. It's just a couple if statements. So now you have, after you do this, you step through all space, you define your C nu, and then what do you do now? Well, you need to update your current. Now that the C nu becomes your current time, which is just C. So C and then so you update that. So your C nu gets put into the current time, and then you go to the next time step. And you do this again. And so this rewrites completely C nu. So you define a new C nu, and then you come here, and that C nu gets placed in our current position, so on and so forth. And at the end, you can print the array. So you might want to have a print array file. Print double array, I think. Yeah, so we'll just do that right now. So I already have one built. It's very similar to what we did out here. It's going to be print double array. I give it a double X, give it a size. Define our array. So we define this function here. Now we can call this function print double array. So our X here, well, it'd be our C. And the size of that guy is the length. And that's it. Oh. So I'm getting 2 warnings. Oh, I'm getting this warning again. Use current, no warning. So remember how to do that. You go to project, properties, pre-compressor there, edit, and then go to the bottom of the list here, and you just copy this text in there. And this is something that's only Visual Studio Microsoft. So succeeded, and we got a couple warnings. Okay, here it's getting, oh, this, so it's saying, hey, this is a double because it's taking these and we're converting to an int. It's like, hey, you're converting to an int, you might lose something. So possible loss of data. Same thing here. H is an integer because it's going in as an index in an array. This is just taking advantage of integer math. This is completely fine. So these warnings, I want these things to be integers. So these warnings are exactly what I want to happen. So you can just disregard. Of course, I'm going to leave this to you, this part. But again, if you have any questions on this, email me. I'm going to be by my email all day. Okay, so the next part I want to talk to you is the moments test. So we in the random number generator, we've created how many random numbers you're creating, and you're going to break up your space. So you're gonna bin you're gonna make a histogram essentially. You're gonna bin all your random numbers into n bins here. And so here's the expected number of random numbers you expect to be in each bin. Y is how many are actually in each bin. So you do this math here, you get the chi-squared, and the closer to 0, the better it is. So let's say we're going to do 1,000 random numbers, and m is going to be 10. So here's this, and here's the scheme here. So m is going to be 10. I'm making an array, 10 big, so 0 through 9. And then what does that represent? Well, so here's our spacing. So random numbers between 0 and 0.1 fall in this bin, 0.2, 3, 4, 6, 7, 8, 9. Oh, and just I was going to put 10. What am I doing? And then 1. So here is where our random numbers go. These are our values of random numbers. And we're going to say 1,000 of them. Well, we have 10 spots, or 10 bins, so we expect we should have, at the end of 1,000 random numbers, we should have 100 in each bin. So let's make a random number. So over here, I'm going to make a random number. And say, let's say our random number, oh, there's something in the background, 0.5. It's going to fall into this bin. So this bin will go from 0, and now it'll have 1. And then let's do another random number. 3, 1. Okay, we come over here. This one gets 1. And so on and so forth. So what I would do to start off is I would make this array with 10 spots and initialize all of them to 0. So 0, 0, 0. They all say 0. Let's even restart everything here. Call this one 0. 0. 0. So here's our initiated array where we're going to, and then first we have this one random number here. So we find this one random number. Oh, okay, it goes in this one. So just repeat what I already did. 1, and then this guy here goes to 1, and then maybe I have, that's the second random number, and maybe random number 3 is 0.9. Oh, that comes over here. No, comes over here. Let's do, no, I don't want to do that. I want to actually have it. Let's do 0.0. That one would come here. Make that one 2. So we need to what we need to do is convert our random numbers that we're generating, our 1,000 random numbers, to, I guess, indexes, right? So we're going to have an index. So we have our it's a chi-square test reform. So if I make a chi-square m array, I'm going to set them all to 0. And then a random number, my Ri, needs to be converted to an index j, and then we can go chi j equals chi j So shorthand for increment, plus, right? So how do we do that? Well, so we have an integer, j. Now let's just set j to be equal m is 10, times our random number. The ith random number. So this would be j of I, right? So let's look at the first one. So let's look at the first one, 0.05. So here we go. Let's see here. Let's actually do this. So, okay. So if R1, let's make a table, R of I and then the j, which equals m times R of I. Now this is going to be an integer. So 0.05. Well, m times 0.05 is 10 times that, so it's 3.5, which means j is 0, right? Because remember, integer, they just look at that first one and drop the decimal. So j is now 0, not 0.5. So we can say, increment it there. So the next one was 0.31. Well, that makes j, times that by 10, you get 3.1. But remember, j is an integer, so that means integer 3. So simply, this becomes the index 3. So that's really all you have to do there. And that's how you program it here. So I call it bin here. So bin is an integer. I have my random number I times the size, which is our m here. And I make this index here, and then I just increment an index. And then that's how you make the histogram. So at the end of 1,000, you should have, each one of these should be a number. And then how far off that is from 100 is what you use. So what these are end up being your y's, right? So right now the first bin is 2. Say I go and I don't have any more in that bin. So when I come here, I'd have y equals 2, but I expected 100, so that's a big error. So something's wrong with my random number generator. Y should be fairly close to your expected. And the more random numbers you put, if you put 1,000,000, it should get even closer. Just remember that that random walker board I had in class. It's very similar here. So I got a few questions on those 2 assignments. If you got any more questions, let me know. Those 2 questions. So if you have any other questions, email me. We can talk. And see you next time.